I want you to picture the typical Tuesday morning for a software developer.
Oh, yeah. The coffee's poured.
Right. You've got your coffee, you sit down, and you look at your architecture diagram.
Mm-hmm.
And it's the standard 3-layer cake that we've been eating for, 20 years now.
The classic stack.
Exactly. You've got your database at the bottom, your client at the top, so web or mobile.
Yeah.
And then sandwiching them together is the server, the backend, the API.
The ubiquitous middleman.
The middleman, yes. Now, I have a question for you, the listener, and I want you to really think about this before you answer. Because, well, it sounds like a terrible idea at first.
It really does.
What if you just deleted the server?
And just to be absolutely clear here, when you say delete, you don't mean hide it behind a cloud provider, like serverless functions.
Oh, no. Gone.
You mean actually removing that layer of the stack entirely.
Trash bin. Not optimizing it, not, shrinking it down into tiny microservices, just taking the API endpoints, the glue code, the serialization, the Docker containers, all of it, and throwing it out. Because today, we are doing a deep dive into a project called SpacetimeDB, and it claims you can do exactly that.
It is a fascinating proposition. It's a project from Clockwork Labs, and despite how radical, almost heretical the idea sounds, they have over 21,000 stars on GitHub right now.
21,000?
Yeah, so people aren't just casually looking at this. They are staring.
Their tagline is, development at the speed of light, which, I will be totally honest, usually makes me roll my eyes.
No, it sounds like standard marketing fluff.
Complete fluff. But when you dig into what they are actually proposing, which is combining the database and the web server into a single unit, it actually might warrant the tagline.
It's a complete collapse of the traditional stack. It's making the claim that the separation of concerns we've held onto as gospel for decades is, well, it's actually holding us back.
Right. So our mission for this deep dive is to figure out if this is pure genius or just architectural anarchy. We're going to unpack how this works mechanically, why they think we should fire our Kubernetes clusters.
Which sounds scary, but also kind of nice.
It does sound nice. And we'll look at a massive multiplayer game that is actually running on this exact architecture right now.
And that game example is going to be crucial, because otherwise this is all just academic theory.
Okay, let's unpack the status quo first so we know exactly what it is we are deleting. Why do we even have that middleman server in the first place? I mean, I know why. I don't want users running raw SQL queries directly against my database.
Drop table users.
Exactly. Drop table users, and there goes the startup.
Right, and that is the primary reason, security and logic. In the traditional model, the client, your browser or your phone, is completely untrusted. You can't let it talk to the database directly because the database historically doesn't know the difference between I want to see my profile and I want to delete everyone's profile.
It just executes what it's told.
Precisely. So we build a server. The server authenticates you. It checks your permissions. It runs the business logic, constructs a nice safe query, talks to the database, gets the result, turns it into JSON, and sends it back to you.
And that middleman layer has grown over the years to become, well, massive.
Oh, it's where all the complexity lives now. It's where you have your caching layers, your load balancers, your 50 different microservices. It's where most teams spend 90% of their time debugging.
Right. And SpacetimeDB looks at that entire mess and says, what if the database was just smart enough to handle the logic itself?
Exactly. So SpacetimeDB is a relational database at its core, but it allows you to upload your application logic directly into the database itself. They call these pieces of logic modules.
Modules. Okay, help me visualize this. Is this just a fancy rebranding of stored procedures? Because I have to tell you, I have actual nightmares about debugging PL/SQL stored procedures from the early 2000s.
You aren't the only one. But no, it's a similar fundamental concept, but the execution is completely modern. These aren't clunky old SQL scripts. You are writing full application code.
In a real language.
Right, currently in Rust or C#. And then you compile that into WebAssembly. That compiled module lives permanently inside the database.
So if I'm building a chat app, for example, the code that says user A sends a message to user B isn't sitting on some separate node.js server. It's literally inside the database module.
Yes. And because the logic is there, the security is there, the client connects directly to the database. But it can only call the specific functions, which they call reducers, that you have explicitly exposed in that module. It's not running SQL. It's just triggering a pre-approved action.
Pause right there. Direct connection.
I know where you're going with this.
Every security audit I have ever sat through has a giant red flag that says never ever expose the database directly to the public internet.
If I pitch this to a traditional CTO today, they're going to literally laugh me out of the room. How is this direct connection not a massive security nightmare? That is the standard knee-jerk reaction, and it's totally valid based on our mental model of old databases. But remember, in this new architecture, the database is the application server. It's not a dumb storage engine anymore. It handles authentication and authorization internally.
Right.
So when you connect to it, you aren't getting a root SQL shell. You're getting a connection to a secure, sandboxed WebAssembly application that just happens to be sitting intimately on top of the data.
Okay, so it's less like exposing your MySQL report to the world and more like the database swallowed the API server whole.
That's a perfect way to put it. It swallowed the server. And because it swallowed the server, you can get rid of all the infrastructure that was previously required to keep them talking to each other.
Which brings us nicely to the Dev-Anu list.
Mm-hmm.
I was reading through their documentation, and they are incredibly aggressive about what this technology eliminates. It is a long list.
It reads like a DevOps hit list.
It really does. No microservices, no containers, no Kubernetes, no Docker, no VMs, no DevOps, no infrastructure, no ops.
It's a pitch for the single binary future.
But let's play devil's advocate here for a second. We didn't invent Kubernetes just to torture ourselves, though sometimes it absolutely feels that way. We invented it for scalability, for resilience. If I delete all that orchestration and I just run one big SpacetimeDB binary, aren't I creating a massive, terrifying single point of failure?
You are definitely trading distributed complexity for monolithic simplicity. That is the trade. Kubernetes is fantastic if you need to coordinate 50 different microservices written by 10 different teams across 5 time zones.
Sure.
But SpacetimeDB argues that for most applications, that is total overkill. Computers are insanely fast now. If you put the logic and the data in the exact same process and the exact same memory space, you don't need horizontal scaling until you hit a truly massive scale.
Because you aren't wasting time on the network.
Right. Think about a microservices architecture. A single user action-clicking a button might trigger 5 different network calls between different services.
And every hop adds time.
That's latency. That's serialization and deserialization overhead. In SpacetimeDB, it's just a direct function call in memory. It's practically instantaneous.
Let's talk about that in-memory part, because that is the other half of their speed claim. They aren't reading off a hard drive, are they?
No. SpacetimeDB holds the entire application state in RAM.
Which totally explains the speed. Accessing RAM is orders of magnitude faster than hitting a solid-state drive. But RAM is volatile. If someone trips over the power cord in the data center, does my entire application just vanish into the ether?
That would be a pretty short-lived database product if it did.
Right, nobody would use it.
No, they solved this with a very standard battle-tested technique called a write-ahead log, or WAL.
Okay, for the folks listening who aren't deep in the database engineering weeds, break down what a WAL is.
Think of it like a receipt tape in an old-school cash register. The actual money, the data, is in the drawer. That drawer is memory. That's where you're working fast, making change, moving bills around instantly.
Makes sense.
But every single time you make a transaction, before you even move $1 in that drawer, you print a line on that paper receipt tape.
So the tape is the permanent record.
Exactly. The tape is written safely to the disk. It's an append-only log. It's incredibly fast to write because you're just adding a new line at the very bottom. You aren't searching or sorting.
Right, you're just writing to the end.
So if the power cuts out and the drawer slams shut, memory is wiped. But when you reboot the server, the system just grabs that paper tape, reads it from the very beginning, and literally replays every single transaction incredibly fast to get the money back in the right order.
So you get all the speed of working natively in RAM, but you keep the safety and persistence of the disk.
Correct. And this entire architecture fundamentally changes how the client interacts with data, too. It's not just about the standard request and response loop anymore.
Yeah, I saw terms like reducers and subscriptions peppered all over the docs. How is that functionally different from a standard REST API?
In a REST API, you ask for data. You send a request like get/messages. The server sends the messages back. Done. But if you want to know if there are new messages 5 seconds later, you have to ask again. You poll the server.
It's like kids in the backseat. Are we there yet? Are we there yet?
Exactly. And it wastes so much bandwidth. SpacetimeDB uses a push model instead. You subscribe to a query. Say, select all from messages where room ID is 1. Because the database is sitting in memory and is actively running your code, The precise moment a new row is added that matches your query, the database pushes that new data down to your client immediately.
Over a single connection.
Over a single WebSocket connection, yes.
So it's essentially real-time by default.
It acts as a real-time sync engine out of the box. You don't write code to endlessly fetch data. You write your client code to react to data changes.
Which sounds absolutely perfect for gaming. And that brings us to the case study, because I think that this is where the rubber really meets the road for this deep dive. It's easy to write a fancy manifesto about deleting servers. It's very hard to run a live MMORPG.
Right. And Clockwork Labs isn't just running a little chat demo to prove their point. They're running BitCraft Online.
And for context, this is a massively multiplayer online role-playing game. We are talking thousands of players simultaneously in a massive shared world, crafting, fighting, moving around. And according to the source material we reviewed, the entire back end of this game is just a single SpacetimeDB module.
It's wild. No separate physics servers, no separate relational databases for inventory, no dedicated microservices for chat. It is all inside the module.
That blows my mind a little bit, because think about what an MMO backend actually has to do every single second. It's not just storing static data like player A has a sword. It's constantly calculating.
That's the key breakthrough here. In BitCraft, the database is handling the procedural terrain generation. It's handling the complex inventory management. But most impressively, it is handling the real-time location and movement of every single player.
So when I sit at my keyboard and I press W to walk forward, that physical input goes straight to the database.
The input goes to the database runs the collision detection logic. Is there a rock here? Can this character actually move? It updates your coordinate in memory, and then, because of that subscription push model we just talked about, it immediately broadcasts your brand new position to every other player standing near you.
The database is doing collision detection math.
Yes.
That feels heretical to a traditional game dev. Usually you'd have a dedicated, highly optimized C++ game server doing the math, and it just lazily saves the final result to the database every few seconds.
But doing it that way introduces latency. That's the rubber banding effect you see in laggy games where you move forward and then snap back. By doing the math directly inside the database transaction itself, you ensure that the state of the world is always perfectly consistent.
Because there's no middleman to get out of sync.
Exactly. If the database says you moved, you moved. There's no desync between a logic server and a storage server because they are the exact same thing.
It's acting as the real-time broadcaster and the ultimate referee simultaneously.
And it's doing it fast enough for smooth real-time gameplay. That really validates their speed of light claim. You simply couldn't do this with a traditional PostgreSQL database sitting behind a standard API. The network latency alone would completely kill the game experience.
It's super interesting, this idea of code living right next to the data. It actually reminds me of something else. It sounds a whole lot like smart contracts in crypto.
It really does, and the documentation actually makes that exact comparison explicitly.
But wait, usually when we talk about crypto on the show, we're talking about expensive gas fees and excruciating 15-second block times. SpacetimeDB isn't a blockchain, is it?
No. And they are very careful to make that distinction clear up front. They state plainly, SpacetimeDB is a database. It has absolutely nothing to do with blockchain. But the architectural pattern is remarkably similar.
How so? Break that down.
Think about Ethereum for a second. You upload a piece of a smart contract to the network. That code lives permanently with the ledger. When you want to do something, you call a specific function on that contract. The network executes it, and it updates the ledger state.
Right, that's the basic crypto model.
SpacetimeDB is using that same concept. You upload a module, which is basically your smart contract to the database, which is your ledger. You call a reducer, which is your function.
I see the parallel.
The massive difference is that Ethereum runs on thousands of distributed nodes with a slow consensus mechanism. So it processes, what, maybe 15 transactions per second globally?
Yeah, 15 if you're lucky and the network isn't congested.
Right. SpacetimeDB is running in highly optimized RAM on a single node or a very tight cluster. It's processing tens of thousands of transactions per second, and there are 0 gas fees.
So it's basically taking the programmable money concept, stripping out all the slow consensus stuff, and applying it to programmable data without any of the crypto baggage.
Precisely. It's the dream of the distributed world computer that crypto originally promised, but actually fast enough and cheap enough to run a massive video game.
That's a great way to frame it. Let's shift gears a bit to the developer experience. because I can practically hear the DevOps engineers listening to this and hyperventilating right now. They're thinking, great, a proprietary black box that runs my entire company's logic. This is going to be impossible to deploy. Is this thing a nightmare to set up?
Surprisingly, no. The workflow is designed from the ground up to be incredibly minimal. They have a command line tool simply called Spacetime.
Very creative naming.
Hey, simple is good. You install the CLI. They have scripts for Mac, Linux, and PowerShell for Windows. You literally just run Spacetime Start. That spins up the standalone node on your machine. You write your Rust or C# code, and you run Spacetime Publish. That is the whole deployment process.
Wait, no Docker Compose files, no setting up Nginx reverse proxies, no configuring complex connection pools and environment variables.
None of it. The entire goal is to aggressively remove all that deployment glue. You just write your business logic and publish it.
I have to admit, as much as I defended the need for Kubernetes earlier, the idea of just typing publish and having my entire backend instantly live is very, very appealing.
It's the developer experience we all actually want.
But we do have to talk about the elephant in the room for any commercial software infrastructure, the license.
Ah, yes. The legal stuff. This is actually a fascinating part of the deep dive because Clockwork Labs had to be very creative here.
Right. SpacetimeDB uses the BSL 1.1, the business source license.
Which is importantly not open source, strictly speaking. Not initially, anyway.
Okay.
The BSL allows you to see the source code. You can use the code, but there are hard restrictions on using it to compete directly with Clockwork Labs. Like you cannot spin up an Amazon SpacetimeDB service and sell access to it.
That makes sense for a startup protecting its core product. But it has a timer on it, right?
Yes, the change license clause. After a set period of time, usually a few years, the code automatically converts to AGPL version 3, which is an officially recognized open source license.
Okay, but hold on. AGPL, that is the scary license for a lot of enterprise companies.
It is deeply misunderstood, but yes, it scares lawyers. AGPL is a strong copyleft license. The viral nature of it means that if you link your software to an AGPL library, or you modify it and host it over a network, you are generally required to open source your own software under the same terms.
Right, and if I'm a game studio and I've spent 3 years and millions of dollars building the proprietary game logic for BitCraft, I am absolutely not going to open source my entire game engine just because I decided to use this database. That would be a complete deal breaker.
It would be. A total non-starter for the exact audience they're trying to reach. Clockwork Labs knew this perfectly well, so they did something really interesting. A legal patch, if you will. They added a custom linking exception to their AGPL terms.
Explain how that exception works in practice.
It basically says, look, we want the core database itself to be open eventually, so the whole community can improve the engine. But we explicitly grant you permission to link your proprietary game module to our database without forcing you to open source your game code.
That is a massive, crucial distinction. It's like they hacked the AGPL license to make it actually viable for commercial business.
Exactly. They want the core tech contributions to come back to them, but they explicitly don't want to punish the developers who are building successful products on top of their platform. It shows they really understand the culture of the game industry, which is fiercely protective of its intellectual property.
So just to recap everything we've covered today, we have a system that completely nukes the middleman server. It runs everything entirely in memory for insane speed, safely backed by a write-ahead log. It handles complex logic like collision detection directly inside the database. And it uses a custom-tweaked license to keep the corporate lawyers happy.
That is the SpacetimeDB package in a nutshell.
It is a incredibly compelling package, I won't lie. But I'm still slightly stuck on the single binary concept. I mean, we have spent the last 10 years as an industry moving away from monoliths. We broke everything down into microservices because we were told monoliths were unmanageable dinosaurs. Are we just violently swinging the pendulum back the other way?
History in tech is always a pendulum. Always. We swung really hard toward distributed microservices because we fundamentally had to solve the problem of web scale for megacorporations like Netflix and Uber.
Right, but we aren't all Netflix.
Exactly. 99% of applications are not Netflix.
That is such a fair point. Most of us listening are building internal tools or B2B SaaS apps or games with maybe 10,000 concurrent users, not 10 million.
Right. And for those normal applications, the massive complexity tax of Kubernetes and microservices is it's just a tax. It's friction. SpacetimeDB is betting that developers are exhausted from paying that tax. They just want to write application logic that works quickly.
It's almost like returning to the raw simplicity of the early web just a PHP file in a MySQL database, but supercharged with the raw power of modern Rust and an in-memory architecture.
That's a beautiful analogy. It really is a sort of retrofuturism for back-end architecture.
So here is the provocative thought I want to leave you with today as you go back to your desk. If a database is fast enough to run an entire MMORPG, natively handling every single footstep, every sword swing, every inventory drop in real time without breaking a sweater, what does that say about the rest of the software industry?
That is the multi-billion-dollar question right there.
We have an entire global economy built around managing complex server infrastructure, massive AWS bills, huge DevOps salaries, entire suites of monitoring tools like Datadog, just to figure out why Service A isn't talking to Service B. If the SpacetimeDB model proves out, are we vastly over-engineering our current web apps? Could we actually be deleting 90% of our infrastructure and getting better performance in the process?
It's a terrifying thought for the major cloud providers, but an incredibly exciting one for the developers actually building things.
I know I'm definitely going to go stare at my 50-line Docker Compose file and just sigh for a while. That's it for this deep dive into SpacetimeDB. Thanks for listening, and we will catch you on the next one.